Good day, sir. Our topic are principles and operations of steam turbine, gas turbine, and dual fuel engines. So the steam turbine. What is steam turbine? Steam turbine is a device that extracts thermal energy from pressurized steam and uses it to do mechanical work on a rotating output shaft. So steam. The use of steam in steam turbine is powered by steam as hot gaseous steam flows past the turbine spinning blades. Steam expands and cools, giving off most of the energy it contains. This steam spins the blades continuously. The blades thus convert most of the steam's potential energy into kinetic energy. Nozzle. So the use of a steam nozzle is a duct or passage of smoothly varying cross-sectional area which converts heat energy of steam into kinetic energy. The shape of the nozzle is designed such that it will perform this conversion of energy with minimum loss. Exhaust. So the use of an exhaust is designed to minimize pressure loss, which would decrease the thermal efficiency of the steam turbine. After the steam leaves the exhaust section, it enters a condenser where it is cooled to a liquid state. Generator. So the use of generator is the primary power conversion component of the power plant. The function of the steam turbine generator is to convert the thermal energy of the steam from the steam generator to electrical energy. So how does steam turbine work? In simple terms, a steam turbine works by using a heat source, gas, coal, nuclear, and solar, to heat water to extremely high temperatures until it is converted into steam. The potential energy of the steam is thus turned into kinetic energy in the rotating turbine blades. Yan na may off cam sa. Ikaw na.
Screen kay pamay.
Nag-share screen ako.
Hindi ka tayo yung PowerPoint kay ba?
Mga ganun man eh.
Basta na kung pamay. Sa kalimubo gamay.
Ikaw na. Steam turbines generally were used.
Basta na yung ibo bay.
Ha? Ano eh?
Basta ibo pa gamay.
Dara day. What is a steam turbine use? Ano eh? Nairog na.
Where is a steam turbine used?
Where is a steam turbine used?
Are found everywhere.
Steam turbines are found everywhere in the planet and are used to turn generators and make electricity to create propulsion for ships, airplanes, missiles. They convert heat energy into form of vaporized water motion using pressure on spinning blades.
Steam turbines can be found
Steam turbines can be found all over the world and are used to power generators, produce electricity, or provide propulsion for machines like ships, airplanes, and missiles.
By applying pressure to spinning blades, they transform heat energy
By applying pressure to spinning blades, they transform heat energy, which appear as evaporated water, into motion.
Busker. Steam turbines were used
Steam
as main
turbines were
engine
used as
in
main
several
engine
kinds of
in
ships,
several
which
kinds
need
of
more
ships
power to
which
propel during
need more power to
1800s to the
propel
mid
during
of 20th
1800s to
century.
the mid of
After
20th
that time,
century. After
the
that
use of
time,
steam turbines was
the
in
use of
decrease
steam turbines was
because
in
of higher
decrease
oil price
because of higher
and the
oil
introduction
price
of new
and the
technologies
introduction of new
as the diesel
technologies
engines
as
and
the
gas
diesel
turbines.
engines and gas turbines.
In
In
1800s to mid of 20th
1800s
century,
to mid of
steam
20th century,
turbines mostly
steam
used
turbines
main
mostly
engine
used as
in
main
any kinds
engine
of vessels,
in
but
any kinds of
as time
vessels,
passes
but
by, especially in this generation, steam turbines are
as time
used
passes
occasionally
by, turbines are
because
used
it is
occasionally
costly and in
because
terms
it
of
is
technology
costly and in terms
advancement.
of technology
Diesel engine
advancement.
and gas
Diesel
turbines is
engine
more
and gas
advanced.
turbines is more advanced.
Gas turbine kan? Gas turbine.
Gas turbine. A gas turbine converts
Ako kung gagkamagay na ka.
liquid fuels to mechanical energy. This energy then drives a generator that produces electrical energy. So there are three important components of a gas turbine, which is the air compressor, combustion chamber, and number three is turbine. So what is air compressor? Compressor. The air is supplied by an air pretreatment unit comprising of a silencer, an air filter, and an air cooler. The ambient air is drawn through these items of equipment before entering the air compressor. This describes a multi-stage axial flow air compressor that compresses the air to high pressure and temperature.
Use the main fuel
Number
powered by
two is
gas
the
turbine
combustion
electrical
chamber.
unit.
This chamber
Main
is
fuel source
situated
is the
between the air
boiler for gas.
compressor
Process the
and
gases
the
to
turbine
extract
and
methane,
supplied with gas or
methane
diesel
gas,
oil
and
and the
methane
high
burning
pressure air.
and
There are numerous fuel nozzles arranged around the combustion chamber, along with two high-intensity spark igniters. Number three is turbine. The hot exhaust, the hot exhaust gas from the combustion chamber drives the turbine, which is normally of two.
The three use the three use of important components in gas turbine, which are the compressor, combustion chamber, and turbine. The air compressor is can help increase the pressure of incoming air before it enters the combustor. Air compressor air compressor performance has a large influence on the total engine performance. So basically, it pressurizes the air so that when it goes into the combustion in combustor, it doesn't need to compress it. Yeah. Combustion chamber. The combustion chamber is the element of the gas turbine arranged between the compressor and the turbine. Inside, which is performed the mixture of the fuel fed by the injectors.
Tama eh.
Wait, sorry. The gas turbine arranged between the compressor and the turbine.
Kan naglag
Inside,
eh.
which is performed the mixture of the fuel fed by
Nagamit
the
is maximo.
injectors with the air fed by the compressor and the combustion of said air and fuel mixture. So, lastly is the turbine. As hot combustion gas expands through the turbine, it spins the rotating blades. The rotating blades perform a dual function. They then drive the compressor to draw more pressurized air into the combustion section, and they spin a generator to produce steam.
Turo. Supo.
This is basically a process of where air is, you know, being compressed and then goes into the combustion chamber and then in turns go into turbine. So major applications of gas turbine is aviation because it's self-contained, lightweight, and it doesn't need cooling. Next is power generation, and then oil and gas industry because of cheaper supplies, fuel, and low installation costs, and then marine propulsion. Gas turbine burns fuel such as oil, natural gas, and pulverized powder or coal instead of using heat to produce steam, as in steam turbines. Gas turbines use the hot gases directly turn the turbine blades.
Ako na ba? Ako na kayo.
Mm.
Dual fuel engines.
Dual fuel engines.
Engines
Engines that operate using a mixture of two different fuels are called dual fuel engines. Frequently, diesel and natural gas fuels are used together with dual fuel engines. Dual fuel engines operate on a primary or main fuel and secondary or pilot fuel. The primary fuel source is typically a gaseous fuel such as hydrogen, or syngas, or natural gas, which is injected into the intake manifold. Dual fuel engine is the engine that can run on both gaseous and liquid fuels. Commonly, diesel and natural gas are used as fuels. Dual fuel engine working principle is it operates on the primary fuel, which is the main fuel, followed by the secondary fuel, which is the pilot fuel. The primary fuel source is typically a gaseous fuel such as hydrogen or natural gas, and the secondary fuel is typically liquid fuel like diesel and petrol.
Ano to? Kulang mo naman. So, mana where is dual fuel engine used?
Yan.
Ay. Kinsa man ni si Kuan?
Where is dual fuel engine use? Dual fuel engine use can be operate on natural gas as well fuel oil. Changeover from one fuel to another can be achieved without any interruption of the power output of the engine. This article explains some more important dual the
Saan pa ni
engine use in a
advantages
gas
dire?
carriers.
Nara.
Simple term is
I-apilan ko na
dual
ako sa
engine
Kuan.
fuel. Dual fuel engine are those that can run on a combination two different fuels. Dual fuels engine frequently combine the usage of diesel and natural gas. How does dual fuel engine work? In dual fuel mode, natural gas is introduced into the engine intake system. The air to natural gas mixture is then drawn into the cylinder just as it would be in a spark engine, which with the linear of air to fuel ratio. The primary fuel source is typically a gaseous fuel such as hydrogen or syngas or natural gas, which is injected into the intake. The secondary, or what we call pilot fuel, is injected into the combustion chamber using the standard fuel injection equipment. It is used to ignite the mixture. How does engine fuel work? The dual fuel engine utilizes as a learn-burn combustion process when operating on gas. The gas is mixed with air before intake valve during the intake period. After the compression phase, the gas air mixture is ignited by small amount of liquid pilot fuel. This pilot fuel is pressure and feeding the cylinder by a small rail of system. Simple term is when the primary is when the engine work and into na nasa ano na siya nasa intake suction point na siya is the gas and the air is combined then those and the second The secondary is the pilot fuel. This is used to ignite the mixture.
Okay na. So, so I forgot to include the advantages of and disadvantages. So, so, sorry. So I will discuss the advantages and disadvantages of steam turbine and gas turbine, also the dual fuel engines. So the advantages of steam turbine. Since the steam turbine is a rotary heat engine, it is particularly suited to drive an electrical generator. The thermal efficiency of a steam turbine is usually higher than that of a reciprocating engine. The very high power to weight ratio compared to reciprocating engines. Steam turbines are suitable for large thermal power plants. They are made in various sizes up to 1.5 gigawatt hours, 2 million horsepower turbines used to generate electricity. Steam turbines have greater reliability, particularly in applications where sustained high power output is required. So the disadvantages of steam turbine: relatively high overnight costs. Steam turbines are less efficient than reciprocating engines at part load operation. They have longer startup than gas turbines and surely than reciprocating engines. Less responsive to changes in power demand compared with gas turbines and with reciprocating engines. Advantages of gas turbine: it is simple to design and construct compared to a steam power station since no boilers are required. Much smaller compared to steam power station of some capacity. Lower operating costs. Less water use since there is no need for a condenser. Maintenance charges are low. Can be started quickly. No standby losses. Disadvantages of gas turbine: problem of starting. Compressor needs to be operating, thus external source of power is necessary. Net output is low since greater power is used to drive compressor. Overall efficiency of plant is low, 20% because of exhaust gas still containing heat. Only efficient in, in a combined cycle configuration. Temperature of combustion chamber is too high, thus resulting in a lower life. So the last one is dual fuel engines. So the advantages of dual fuel engines. Dual fuel engines reduce the environmental impact of oil and gas operation. Dual fuel engines deliver financial savings through reduced diesel fuel consumptions. Dual fuel engines operate with diesel-like performance. Disadvantages of dual fuel engines. Dual fuel conversions suffer from major increases in carbon monoxide or CO and hydrocarbon or HC emissions and loss of fuel efficiency at light loads. This is because they operate unthrottled, so that the air fuel mixture becomes leaner as the load is. So that that is our report, sir. Thank you.
Thank you, sir.